Welcome back. So we're going to be looking at problems on scalars and vectors. We're going to be trying to apply the concepts and the formulas we've gathered from the class into solving real life problems. Okay, so we have a couple of problems here, about 4 of them. Okay, this is the first 2 and we have another 2 here. All right, the first question is: a body is under the action of 2 forces, 7 newtons and 10 newtons. Find the resultant of the 2 forces if A, the forces are parallel and act in the same direction; B, the forces are parallel and act in opposite directions; C, the 2 forces are inclined at an angle of 60 degrees to each other. If the figure here represents these forces, okay, this figure represents the body that is under the influence of these forces, okay, 7 newtons and 10 newtons, and they are both acting in the same direction and are parallel. All right, if we want to know the resultant, if we want to know the effect of this force on this body, what we do is sum both forces, because they are in the same direction. We sum both of them to know what the effect will be. So we have 7 newtons plus 10 newtons, which give us 17 newtons. Of course, it's going to be in this direction. The effect is going to be felt in this direction. So B, the forces are parallel and acting in opposite directions. So if this represents the body, and of course this is the forces, 7 newtons, 10 newtons in opposite directions, what's going to be the effect of these forces on this body? Now we can get to experience the reason why vectors can't be completely described by their magnitude alone. You have to also consider their direction. Okay, so let's see this. If we want to find what effect this body will feel from both forces, now we're going to still sum both forces to get the effect. But if we sum them without considering their direction, we're going to get a very wrong analysis of the whole situation. Okay, because 10 newtons is acting in one direction, 7 newtons another direction. If we want to know the effect of both forces on this body, of course it's to sum both forces, but then we have to understand that their directions are different. So if we assume this to be acting on the positive x-axis and this on the negative x-axis, so we can then sum this up to be 7 newtons plus minus 10 newtons, and we'll see that what we'll be left with is minus 3 newtons, and this minus here is going to show us that this 3 newtons is going to be felt in the negative x-axis. So it's going to be felt in this direction, this direction, this direction. So what it means is, if let's assume a guy is pulling this object in this direction by 10 newtons, another guy is pulling in this direction by 7 newtons, we're going to have this body experience a 3 newtons force only in this direction. It's just going to experience only a 3 newtons force in this direction, so it's going to move in this direction. All right, so I'll see what if the forces are inclined at 60 degrees. What's going to be its resultant? So we have something here to depict that. We have a body, we have 7 newtons, 10 newtons, both acting at 60 degrees to themselves. So if we remember from the parallelogram law of forces, if we have 2 forces that are acting at a point, okay, and can be represented by the adjacent sides of a parallelogram, then the resultant of those forces is the diagonal drawn from that point. So basically, if this and this are the 2 forces, of course we can represent them with the adjacent sides of a parallelogram, because we can draw a complete parallelogram like this. But that aside for now, let's bring in the law of cosines, the formula for the law of cosines, to solve this problem. Okay, so we have r squared equal to p squared plus q squared plus 2pq cos theta. From the parallelogram law of forces, we can say that we have a diagonal this way. Okay, we have a diagonal that way, and this represents the resultant of the force, okay, and that will go to mean that the effect this body is going to experience is going to be in this direction. It's obviously going to move in this direction because that's the effect of both forces it will feel. Okay, but then if we have this as our arrow, if we take 7 newtons to be our P and 10 newtons to be our Q, we have 7 squared plus 10 squared plus 2 times 7 times 10 cos 60. If we simplify this, of course, we're going to have 7 squared to be 49, 10 squared to be 100, 2 times 7, 14 times 10, 140 cos theta. Okay, remember that from BODMAS, you can't just go about solving a group of numbers like this without understanding where you have your brackets. So of course we know we have a bracket here, okay, and it means from BODMAS where we should tackle our brackets before indulging any number inside here with the ones outside here. So of course this is even a multiplication sign, so we have 2 times 7 times 10 to give us 140 cos 60. So we have plus 140 cos 60, we have 10 squared 100, 7 squared 49. Okay, so finding the roots, the square root of that, and we would eventually have our answer to be 14.8 newtons. Okay, so let's try to find the angle of the resultant. We weren't told to find that, but let's try to do it. Okay, so if this is the same forces, 7 newtons and 10 newtons acting at an angle of 60 degrees to each other, of course you can see I've just drawn the diagonal. So this is the diagonal of the parallelogram and happens to be the resultant of both forces. Okay, so if we now complete our parallelogram like this, we can now bring in the properties of a parallelogram and use them to solve this problem. So we remember in a parallelogram that opposite angles are equal, right? So if this is 60, obviously this will be 60. All right, and remember that all the angles in a parallelogram sum up to be 360. Okay, so in that case, if this is 60 and this is 60, it means we have both of them to sum up to 120. So 360 minus 120 would give us 240. So it means these two angles sum up to be 240, but both of them are equal. So if we divide 240 by 2, we'll find out that we have 120, and both of them happen to take that value, 120 degrees, 120 degrees. So now we have all these. What is the angle of our resultant? We can use the sine rule to try to find our answer. All right, so we can take any of these parts of the triangle. Okay, we have two triangles here. We can take any of the parts to try to solve this problem, but for this particular example, we're going to take here to be the angle we're looking for. Okay, so this is the angle we're looking for, and that would be alpha. All right, okay, so this is the angle we're looking for, and that's alpha. So using the sine rule, we have sine alpha over BD, all right, equal to sine D over AB. So this is sine D. Remember, we're dealing with just this triangle, just this triangle. So we're trying to find this angle. Okay, the angle the resultant makes with line AD. Okay, now if we make sine alpha the subject of formula, of course we're going to be having sine alpha equal to sine D, which happens to be 120. This is D and this is the angle D. So sine 120 times BD all over AB. Okay, we know that BD, okay, is equivalent to this AC, or the 7 newtons, both in magnitude and in direction. Okay, you can see AC is same with DB, both in direction and so magnitude too. So we can deduce from that BD is 7 newtons. The same thing with AD and CB. Okay, so but we already know that AD is 10 newtons in this case. Okay, but we're looking for sine alpha and we need AB. All right. So how do we get our AB? Okay, so of course we know our AB already because we had gotten our AB previously as 14.8 newtons. So we can simply put all we have into the equation. So if we make alpha the subject of formula, here we have arc sine. Okay, we have arc sine 120 times BD, which is 7 newtons. Okay, and AB, which happens to be 14.8 newtons. If we simplify this, we're going to have 24.18 degrees. So, and this 24.18 degrees is, remember, it is towards the 10 Newton force. It's towards the 10 Newton force. All right. Let's consider D. The two forces are inclined at an angle of 90 degrees to each other. So we have 7 and 10 inclined at 90 degrees here. Okay. Now, if we reproduce this diagram here, we can see that it's, of course, this is just drawing the forces without the object. You can see that it represents two sides of a triangle. Okay, it represents two sides of a triangle. That means the third part of that triangle will represent our resultant. Okay, but then let's remember that the two adjacent sides of the triangle should be taken in order. Okay, so if we look at this and this, they are both out of order. This is going this way, this is going this way. So we have to take the sides that are in order. All right, so that was why in the class I made us understand that we should always consider that our angles, our vectors are tail to head. Tail to head. You can see this is tail to tail. For the 7 and 10 newtons, this is tail to tail. If we have them tail to tail like this, and we try to get and we try to draw a resultant as the third part of that triangle, then we're not going to be right. Okay, so what we need to do is to take the side. Of course, you know, this side AD and this side BC are equivalent both in magnitude and direction. Okay, so we can assume we are moving this to this side, we are sliding it to this place, or we can just assume that yes, we are taking this side because this side is equivalent to this side. So we have AB BC, where AB is 10 newtons, BC is 7 newtons, and you can see it's going to be tail for this guy to head. The head of AB will be touching the tail of BC. Okay, so if that happens, then AC becomes our resultant. So in that case, now we can solve for our resultant and then solve for the angle of the resultant. The angle we're finding is going to be the angle it makes with the x-axis, which is the AB, and that's written here. The angle is represented here as alpha. All right, so we're going to be finding our resultant using the Pythagoras theorem. So we know AC squared is equal to AB squared plus BC squared. Okay, for right angle triangles. So of course, this is going to be 10 squared plus 7 squared. If we find the root of that, we are going to have 12.2 newtons. Okay, now that's our resultant. I need to remember that this is the part we use to find our resultant. So AB BC, you can see this is pointing down, is equivalent to this one pointing down. In magnitude, it's 7 newtons, and in direction, so we do AB BC. Okay, we didn't take AB and AD. You can see AB squared plus BC squared, and you can see it's also 90 degrees here. All right, so that's how we get our resultant. All right, then we have to try to find alpha. How do we find alpha? We can bring in the sine rule. Okay, so sine alpha, this sine alpha, we take the side that's opposite that angle and divide it by sine alpha. So we have BC equal to sine B. Okay, so this is sine B, which is 90 degrees, and then we take the side opposite it, which is AC. So that's how we make up the sine rule. Okay, so this is going to be giving us sine alpha equal to, making sine alpha subject to the formula, sine B, sine 90 times 7, which is BC, okay, which comes up there, all right, divided by 12.2, which happens to be the resultant, AC. All right, so if we simplify this, we'll be having sine alpha equal to 0.574, and then arc sine 0.574 would give us 35 degrees. All right, and this is towards the 10 Newton force. So if we have both these forces at 90 degrees, we are going to be having our resultant to be 35 degrees towards the 10 Newtons force. So we can say, of course, 35 degrees eastward if we need to say that. All right. Okay, so we'll move on to the second question. Okay, so a lawnmower is pushed with a force of 50 newtons. If the angle between the handle of the mower and the ground is 30 degrees, calculate the magnitude of the force that is pressing the lawnmower. Then also 2, calculate the magnitude of the effective force that moves the mower forward. All right. Okay, so the first thing we do is to try to get the representation of the whole concept. So a lawnmower is pushed with a force of 50 newtons. So we can see that we have this box representing the lawnmower, and we have this line representing the force of 50 newtons on the lawnmower at an angle of 30 degrees. You can see that it's between the handle of the mower and the ground is 30 degrees. So we have 30 degrees to the ground. Okay, and they're asking us to calculate the force that is pressing this lawnmower into the ground. All right, so what do we think is the force pressing this into the ground? The force pressing it into the ground will definitely press it in this direction. All right, in this direction. So that's going to be the vertical component of this force, 50 newtons, because that's the force that's going to be pressing this object into the ground. All right, so we find the vertical component of this force. So that will be Vy equal to V sine theta. Okay, and that will be 50 newtons sine 30. And of course, that will give us 25 newtons. So out of these 50 newtons, we have only 25 newtons pressing this box into the ground. That's the force the box experiences in the vertical direction. Okay, so next we are asked to calculate the magnitude of the effective force that moves the mower forward. The effective force that moves this mower forward is obviously the force that acts in the horizontal direction. Okay, so we're going to do the same thing, find the force that acts in the horizontal direction, and if we do that, we know we're going to find that by doing V cos theta, and that means we do 50 cos 30, and that gives us 43.3 newtons. Okay, so basically remember that we always use the angle, the force mixed with the x-axis. Okay, so we can always use sine for the vertical and cos for the horizontal. Okay, so let's move to the third question, and it says a ship sets out to sail to a point 120 kilometers due north. An unexpected storm blows the ship to a point 100 kilometers due east of its starting point. How far and in what direction must it now sail to reach its original direction? Okay, so let's draw something to depict the motion of this ship. Okay, so from the question, we see that the ship wanted to sail to this point. A ship sets out to sail to a point this. It wants to sail 120 kilometers northward, but then a storm blows it 120 kilometers due east from its starting point. It blew it away from where it wanted to go. Now the question is, how far is it away from this point where it should be, and in what direction must it now sail to get to that point? Okay, so we can find AB by using the Pythagoras theorem. AB squared equal to AC squared plus BC squared. So we're going to be having 100 squared plus 120 squared, and we find the root of that, and that will give us 156.2 kilometers. So we see this guy has to move 156 kilometers to get back to where he was, to where he wanted to be from C. he has to move 156 kilometers. To find in what direction he has to sail to reach that point, okay, we find the tan of theta. Okay, so remember, we're looking for the angle AB makes to the x-axis, and if we're doing that, tan theta is opposite over adjacent. I'm sure we know that from trigonometry in maths. Okay, so tan theta is the opposite over adjacent. If you're not very sure of all these maths concepts, look out for our maths courses and take them and get the understanding that you need. So tan theta is opposite over adjacent, and opposite is BC. Of course, it's opposite the angle, and we have the adjacent to be the 100 kilometers. So we have 120 kilometers over 100 kilometers times arc tan, because we made theta the subject of formula. So okay, this would give us 50.2 degrees. Okay, so this is 50 degrees north of west. So let's look at the fourth question. A person desires to reach 3.4 kilometers from her present location and to a point that is 35 degrees north of east. However, she must travel along streets that are oriented either north-south or east-west. What is the minimum distance she could travel to reach her destination? Okay, so let's draw something that can help us understand this question. Okay, this lady desires to reach 3.4 kilometers from her present position. Okay, this is where she is. She wants to move from here to a position that is 35 degrees north of east. So of course, this is 35 degrees north of east. Okay, and she wants to be 3.4 kilometers away in that direction. So it means she is here, but she wants to get to this point. Okay, but then she can't just travel straight. She has to go through streets that are oriented north, south, or east, west. So she has to go through, of course, this is north, this is south. So she has to go through streets that are oriented this way or this way. Okay, now the question is, what is the minimum distance she could travel to reach her destination? Okay, so she is here. She wants to go here, but she has to go through this north-south orientation kind of street and the east-west orientation kind. So she can go walk this way and then walk this way to get to her point. What is the minimum distance she will travel? What they're asking us to find is to find this distance BA or AB, right? Because that's the minimum distance she will travel if she has to go through streets that are oriented this way. Fine, so now we understand that. How do we find A and B? Remember, we took the top side of this triangle, so instead of us to work with 35 degrees, we have to subtract 35 degrees from 90 degrees to get 55. Okay, so we're working with 55 degrees here. What can we do to get AB? First of all, we can find A, and to get A, we have to use sine theta. Sine theta is opposite over hypotenuse, and if this is theta, of course, this is the opposite, and this is the hypotenuse. So that leaves us with one unknown value, so that is A over 3.4. We know our theta to be 55, so we have sine 55 times 3.4 will give us A. Okay, we made A the subject of formula. If we multiply this out, of course, we're going to have 2.79 kilometers for A. So we have found A. We now want to find B. We can find B by, of course, using the Pythagoras theorem. We can also find B by finding tan theta. Okay, tan theta is opposite over adjacent. Of course, these are opposite and these are adjacent. If we do that, we'll get same answer. But let's use Pythagoras theorem, okay, to find B. So we're going to be having, of course, we know that 3.4 square is equal to A square plus B square for Pythagoras theorem. And of course, this is our resultant part of the triangle. So 3.4 squared equal to 2.79 squared, which is A squared plus B squared. Okay, so if we make B the subject of formula, we have this 3.4 squared minus 2.79 squared. And then if we find the square root of the simplified right hand side of this equation, we're going to have 1.94 kilometers as our B. So what is now the minimum distance that she will travel? That would be 2.79 plus 1.94 kilometers, okay, which would give us 4.73 kilometers. Okay, so this is what we do to find that answer. It might seem like you can't easily understand these concepts, but I can assure you, once you get to understand the basics of how to manipulate the word problems and you know the formulas, then you're good to go. So I would advise you keep trying questions. If you have any difficulty, you can make a comment or reach out to us, and we would help you to, get your answers.